All right, day 2 of lesson 6.3. Okay, yesterday we left off with talking about 2 different types of logs. What are they?
Common log and natural log.
Good job. Common log and natural log. I'm going to ask you this. Are they the same? No. What's the difference between them? Bases are the same. What's the base of a common log? 10. What is the base of a natural log? E. Okay. This E is much like pi. Not the pie you eat. Pi, like 3.14159, all of that, right? Pi goes on and on forever. That's what E does. E just goes on and on and on and on forever. Okay, so that's just an exponential number that we can think of as a variable. Okay, what I want you to know about this E, though, is it is an exponent. Okay, it's exponential. Okay, so just keep that in mind. That'll make more sense when we get into a problem here. Okay, but biggest thing, that common log has base 10, natural log has base E. What I want you to know is that log, base 10, those are kind of inverses of each other. What I mean by inverses is that they essentially can cancel each other out. Okay, when we're trying to solve equations. Same thing with natural log and E. Those can be used as inverses. They can cancel each other out when in an equation. Okay, so let's look at example A here. I'm going to ask you this. Is it common log or is it natural log?
Common.
Why do you say common? Because it has base 10. Good. Common log because it has base 10. How do I know that is a base? That's the one that holds the exponent, right? It's the number of the exponent. So what did I say is the inverse of that base 10? Log, right? So what I'm going to do is I'm going to log both sides. What I do to one side of the equation, I have to do the other. Okay. So if I rewrote this, on the left side I have log of 25 equals, what's going to happen to this log in 10? Yep, so I'm left with x minus 1. Okay. Now, from here, our whole goal still when solving equations is to get x by itself. What would I normally do right now to get x by itself? You're exactly right. I would add 1. Well, how do I add 1 to log of 25? It does not turn to log of 26.
Oh, that would have been awesome.
Okay, so this is where our calculator comes in. We're going to do a lot of this in our calculator. So type in log of 25. Make sure you hit enter. Hit enter. What do you got?
1.4979.
Yep, that 1.39 is what you should have, right? Now, after you hit enter, go ahead and click plus 1. Okay, so you got to do all that separately. What do you get when you do that? X equals? Yep, and yesterday, how many decimal places did we do? 4. So 3979. Okay, so a lot of using the calculator. Let's look at example B. Now, how is B different than A? It's a natural log this time. Yep, what gave away that it's a natural log? It's the ln. Yep, it's an L. It's a ln, natural log. So, looking at this example, how do I... Okay, do you agree x is kind of closed off right now? Okay, how can I open it up by getting rid of this? What's the inverse of ln? It's the base, right? Base E. So I'm going to take E to both sides because what I do to one side, you do to the other. What happens on the left? Yep, these cancel out, so I'm left with 2x plus 3. Now, remember what I said about E. That's going to be for exponential form. So this turns into e to the 4th power. You don't really have to worry about that because when you hit the E button in your calculator, it turns it into an exponent for you right away. Okay, so what would I normally do here to get x by itself? I would subtract 3. How do I subtract 3 from e to the 4th? Calculator. Yep. So in your calculator, find that E button. You're going to hit second natural log. Hit second natural log, and it's going to open it up for you. Okay, second natural log, and then hit 4. What do you got in your calculator so far? Should have 54.5981. Okay, so then what did we say is next? Yep, subtract 3. Keep it in your calculator. What do you have now? Yep. I'm just going to write down this for now so that I can model it for you. blah, 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 blah. What's the last step to get x by itself here? Divide by 2. So in your calculator, leave that big decimal in there, and then take divide by 2. What do you have? 799. That would actually round up to 1. Yep. So when you are doing all of this in your calculator, you don't want to find e to the 4th and then hit clear and then try and do -3. Okay? Keep that number in your calculator all the way until the end. Cool? Okay, that'll help you get your exact answers that you need. Let's go ahead and take a look at your example 5A and B. Now, these do look a little different than the ones that we just saw, but that's okay. That's good to see different examples. So on A, we have log of 3x minus 2 equal to 2. How are we solving equations yesterday? How are we solving logs yesterday? What did we do first? First of all, what's my base in this problem? Remember, usually I would have like a 5 here yesterday or something. But if there's nothing there, what's my base? 10. It's that common log, right? So you can go ahead and put a 10 there. Okay, we can act like our base 10 is there. So with this, to solve a log, we want to write this in exponential form to make it easier for ourselves. So remember, that's the circular method we talked about. Always start with the base. What's my base? 10. So 10 to the second equals 3x minus 2. You're right. You're one step ahead. So we're rewriting in that exponential form, so that goes in the circular motion. Start with your base, and then you go in a circle. Okay? How can I solve this equation here? How would I normally get x by itself? I would add 2. How do I add 2 to 10 squared? Figure out what 10 squared is first. What's 10 squared? 100. So we have 100 equals 3x minus 2. Now this looks like a comfortable algebra problem that we're used to. What do I do next? Add 2. So we have 102 equals 3x from here. Divide by 3. What'd you say we get? X equals 34. So when you start with an equation that has log in it, you're going to want to rewrite into exponential form first, because when we rewrote it into exponential form, did that make it a lot easier to solve an algebra problem? Okay. What about 5b? How is this one different? Right. Is that common log or is that natural log? Natural log. Okay. Do you agree this x is kind of closed off? Okay, how can I open it up? How do I get to it? What's the opposite of e? Natural log, right? The inverse, okay? So we're going to natural log both sides. What happens on the left? Yep, these cancel each other out, so I'm left with x plus 2 equals, now this just turns into natural log of 8. Okay, what do we do with that natural log of 8? Put it in your calculator. So everyone type in natural log of 8, hit enter. What do you have so far? Good, 2.0794. What's my last step to solve? Subtract 2. Yep, so we get x equals, what do you get when you add 2?
When you add 2 or subtract 2?
Sorry, subtract 2. Yep.
0.07.
Yes, and again, how many decimal places do we do?
4.
0794. With logarithms, do 4 decimal places. Let's look at these. Do you understand problems together? So on number 4, I'm going to ask you this. Is this in log form or is this in natural log form? It's in log form. Like, we don't see an e, right? So we know this is in natural log form. So this is where we can do our circle method. Okay, so we want to go into logarithmic form. So obviously I need log. What's my base? 2. So log base 2 of what?
64.
1 over 64 equals, circle back around, -6. Okay. Number 5, is that natural log or is that common log?
Natural.
Natural log because of that e, right? So, how do I get rid of the e?
LA.
Natural log. Yep, I'm going to natural log both sides. What happens on the left?
Oh, again.
Yes, but these cancel out, so I'm left with 4. This little squiggle equal sign, it means equal, but there's normally more decimals here. They just rounded. So that's why they have that squiggly equal sign. Okay? But this just turns into natural log of 54.6. And then we're done. I know we're done because all it wanted us to do was rewrite in log form. This one over here is in common log form. This one is in natural log form. Okay, so that's all we needed to do on those. Now, on 6 and 7, we're going backwards. So now we're going from logarithm form to exponential form. So, on number 6, what can I kind of fill in there that's not there? The 10, right? That's our base term. So, always start with the base. What is my base? Bless you. What is my base term on number 6? 10. Circle method. What's my new exponent? 2.301 is equivalent to 200. Okay, use that circle method to help you. That tells you the order that you're going to put them in. Okay, so you go from base to the exponent to what it equals. Okay. All right, number 7, common log or natural log? Natural log. So what are we going to use? The base e. So what I do to one side, do to the other. What happens on that left side there? They cancel, so I'm left with 25 is equivalent to, remember we just rewrite that as e. Where should I write that 3.2 at? As an exponent. Yep, remember that e, we want an exponent there. So, do you agree both of these are in exponential form?
Yeah.
Yes, okay. How I know this one right here is an exponential form? We have an exponent. Okay. How do I know this one's an exponential form? It has that base e, right? And it has this exponent, but it has this base e telling us it's an exponential form. Okay. Now we're getting into the second thing we talked about yesterday, which is finding what that actual value is. So in order to find that value, we want to rewrite in exponential form, okay? Because that's going to help us. So again, where do I start? When I rewrite, where do I always start? The base, right? So base 4, what's my exponent? X, yep. Put yours equal to x, because that's what we're looking for. So our exponent is x equals what? 64. So now remember, this is kind of guess and check right now. How do I find x? It's how many times 4 is being multiplied to get 64. So keep taking 4 times 4, however many times in your calculator. How many times do you have to do that to get 64? It is 3. Yep, so x equals 3. Okay, number 9 is a similar idea, but what are we missing? The base. What is the base if nothing's there? Yep, it's our common log, base 10. How do I rewrite this into exponential form? 10 to the x equals 1 over 100. Okay, so, what do I know about this x value? What's it have to be to get a fraction? Has to be negative, right? So how many times do I have to multiply 10 to get 100? 10 times 10 equals 100, so you have to do it 2 times. Okay? What's nice about the common log, though, you can actually use your calculator on that one. Okay? So if your base is ever 10, you can automatically just plug that into your calculator. So everyone try that. Type log of 1 over 100. So 1 divided by 100. Get -2. Yep. Can I use the log button if my base is not 10? No. Okay, you can only use the log button if your base is 10. Awesome. Last 2 here. Number 10. What are you thinking? It's a natural log. They do. Yep, remember that natural log and e, those are inverses of each other. So it cancels, and I'm left with, yep, if I set that equal to x there, that means x is equal to 5. Yep. So remember, that natural log and that e, they're inverses of each other, so they cancel each other out. Okay. All right, what about 11? We're solving for x now. Do you agree, what's kind of in the way right now? Before the e, what's in the way?
4.
The 4. What should I do with that 4?
Get rid of it.
By how?
Subtract them. Divide.
Right, why should we divide?
That's my bad because there's only 2 numbers. This is a big number.
And they're multiplying.
Yeah.
So I want to divide by 4 on both sides. So type 7 divided by 4 on your calculator. You should have 1.75 right now. Leave that in your calculator. What's the last thing I need to do to get x by itself? How do I get to that x?
You guys.
How do I get rid of this e? Yep, natural log. What do you do to one side? Do to the other. What happens on the left side there? Cancel, I'm left with x equals, what do I do for that right side? I have natural log of 1.75. What do I do with that? Yep, put it in your calculator. Yep. Type in natural log of 1.75. You should get what? 0.5596. Again, how many decimal places?
4.
We want 4.